In this video we'll talk about inverses and compositions and how the two relate. So in previous videos we've talked about compositions and we've also talked about inverses. So if we think back to compositions where we take f of g of x, for instance. Well, the idea is that we're taking domain values, we're moving to the range of f, so there's f of x, and we're going from here to g of x. And f of g of x just gives us a way to go all the way through. Cut the corner, if you will. However, what if I compose a function with its own inverse? Well, normally a function takes me from an x value to a y value. And an inverse is going to pull me right back. So I'm doing this kind of circular motion if I do it all in one fell swoop, which means I'm going to go back to what I start with, which is x. And that would be it. Likewise, if I compose an inverse of a function with its original, I also get x. And this is one way to verify that two functions are indeed inverses. If I compose the two and I get x on both, then I know they are inverses for all values of x. So let's take a look at an example. I want to determine if g of x equal to x plus 2 and f of x equal to x minus 2 are inverses of each other. Now there's two ways you can go about doing this. The first is that, okay, I can take g of x equal to x plus 2 and I can find its inverse. We could go through, we can say y equals x plus 2, switch the variables, and then keep going. So we'll have x equals y plus 2, y equals x minus 2, and that is my inverse, so these are inverses of each other. We'd also have to verify that it works the other way. So I have to take f of x. So f of x equals x minus 2, and then turn it into x and y's instead of with the f's, and then switch. Then we can go and say x equals y minus 2, get y by itself, x plus 2 does equal y. And then I've verified it works this way. So I've verified both of them are inverses of each other by saying, yeah, if I find the inverses for each, that's what they are. However, another way is I can just compose them. So let's take g of f of x. Well, this means that everywhere I see f of x, or everywhere I see an x in g of x, I'm going to plug in f of x to it. So I'm going to have x minus 2, in parentheses, plus 2, which is x. So that tells me that f and g are inverses one way. F is the inverse of g. Now I have to test it the other way. Sometimes there are functions that work one way but won't work the other. So g could be an inverse of f, but f might not be the inverse of g. So I've got to test it. F of g of x. And this means that everywhere I see x in f of x, I'm going to plug g of x in. So I'm going to have x plus 2 minus 2, which is x. So in this case, it works out f and g are inverses. And a way we can write that, f of x equals inverse g of x, and g of x equals inverse f of x. Two methods here, both are equally valid, just two ways of doing the same thing. So let's take a look at another example, one that's not quite so clear-cut. I want to know if these two functions are inverses of each other. Now, I'm going to go ahead and jump right to the composition method. I personally like that one. So here's what we're going to do. We're going to say find g of f of x, meaning everywhere I see x and g of x, I'm going to plug f of x in for it. So I'll get 2x plus 3 all divided by 2 minus 3. Now at this point I can do a little simplification. So this is going to turn into x plus 3 halves minus 3, which means that I'll have x minus 3 halves. I had to think about that one for a second. So, most importantly here, this is not equal to x. So then I can say g and f are not inverses of each other. And I don't have to compose the other way because it didn't work out this way. I already know they're not inverses of each other. So I can stop.